Hey everybody, my name is Ankit Singh, student of BE Computer Science and Engineering, and today we are going to discuss about syntax analysis and compiler design, which is from the subject Automata Theory and Compiler Designs. So here's the introduction part. When an input string or the source code is given to the compiler processes it in the several phases, starting with the lexical analyzer to the target code generation. Actually, guys, as we all know that our computer does not understand our high level languages like English or Hindi, like these languages computer does not understand. So it only understands the two numbers, only zeros and ones. So we need a medium which converts our high level language to machine level language. In this case, compiler comes into the picture. The compiler is having the different phases of this conversion. It starts from lexical analyzer, which converts our high-level languages into the small tokens. Then it send it to the its lower level, like 2, 3 phases are there, and at last target code generation will be there. So in that, the syntax analyzer or syntax analysis is the second part, means the second phase of this compiler design, as it is written in the next paragraph. The syntax analysis or parsing, the syntax analysis also known as parsing, is a second phase after lexical analyzer. So it checks the syntactical structure of the given input. So guys, as we all know that in any programming language, we need to follow some certain rules. Like in C or Java, they are having different syntaxes of declaring an array. So for both the compilers, they will check the syntactical errors, like semicolons are there or not, the array size is defined inside the square brackets in case of Java or not, the data type is same in both LSs or SS or not, like that. And if it's correct, then it will does the following processes as discussed in the next PPTs, or else it will return an error. So guys, here is the different phases of compiler. Like it starts from source program. Then I told the first phase of compiler design is lexical analyzer, and then it will go to syntax analysis as our topic of discussion today. And then it will send it to the intermediate code generation, then optimization of the code happen, and then the target code will be generated, and the target program is been executed by the computer. In this case, anywhere if there is any error, then it will check to the error handling, send to the error handling, and again it will go to back to the phase where it was located. And there are some table management also there that they will also send back to the required destinations. So here's the introduction to the syntax analyzer. It does so by building a data structure called parse tree or syntax tree. The parse tree is constructed by using predefined grammar of the language and the input string. If the given input string can be produced with the help of the syntax tree, the input string is found to be correct syntax. If it is not, the error is reported in the syntax analyzer. So the process of generation of syntax is being defined here. So how it does? So it does so by using a data structure, and the name of data structure is parse tree. In that parse tree, if the some predefined grammar rules are there, if the language is being constructed by using that certain rules, then it will produce the output, or else it will return false. The syntax analysis, also known as parsing, is a process in which the compiler design where compiler checks the source code follows the grammatical rules or not. Typically the second stage of the compilation process, as discussed before also. And the main goal of syntax analysis is to create parse tree or abstract syntax tree. It is also known as abstract syntax tree or parse tree, both are same, of the source code, which is a hierarchical representation of source code that reflects the grammatical structure of the program. So it's the grammatical, means top down or bottom approach of checking this grammar. So there are several types of parsing algorithms or syntax analysis algorithms are there. There are mainly four, and each are having their own advantages and disadvantages over other. So first is LL parsing. This is also known as top-down parsing algorithm that starts with the root of the parse tree and construct the tree by successively expanding non-terminal. The LL parsing is also for its simplicity and ease of implementation. Actually, guys, this LL parsing is the top-down approach. Like it will start from the root node and expand all the nodes which are related to its child nodes. And it is very simple in implementation. And the second is LL parsing. It is also known as bottom-up parsing algorithm. Starts with the leaf node of the parsing and construct the tree successively by reducing the terminals. The LR parsing is more powerful than LL parsing and can be handled in a large class of grammars. Like if we are having very large class of grammars, large number of loops, so we use LR parsing over LL parsing because it is having if it starts from the root node, we are starting from the result and we will only go to that terminus which is required for our tree. And then there's LR1 parsing, which is the upgraded version of LR parsing. This is a variant of LR parsing that is uses lockhead disambiguate the grammars. And then LR parsing. This is also a variant of LR parsing that uses reduced set of lockheads. So here the lockheads are being used, but here reduced set of lockheads is being used to reduce the number of states in LR parsing. So here is the features of syntax analysis. The syntax tree, as we all know, that first the syntax analysis of the parsing tree is being generated. So it's a feature of the syntax analysis. The syntax analysis creates a syntax tree, which is a hierarchical representation of code structure. The tree shows the relationship between the various parts of the code and including the statements, expression, and operators. So it will represent everything like our statement, what is our statement, our expressions like with plus and every operators also been represented. The context-free grammars or CFGs. The syntax analysis uses context-free grammar to define the syntax of the programming language. A context-free grammar is a formal language which is used to describe the structure of the programming language. A CFG is nothing but a something that is a grammar which is used to define the formal languages of the code structure. And the top-down and bottom-up parsing. So these are the two approaches. We can start from root node, or either we can start from the child node. So the syntax analysis can be performed by using two main approaches, top-down parsing and bottom-up parsing. Top-down start from the highest level, means root node, and bottom start from the lower level or the leaf node. And here's some the continuation of that part. The error detection. The syntax analysis is responsible for detecting the syntactical errors in the code. If the code does not conform the rules which is given or the grammatical rules which are given, it will throw an error. And the intermediate code generation. So the intermediate code generation, in this part, the syntax analysis generate an intermediate representation code which is used by subsequent phases of the compiler. And the intermediate code representation is usually more abstract form of the code, which is easier to work with the source code. And the optimization. So the syntax analysis, as we all know, if it is analyzing our code earlier only, the syntax are not there. So overall, it is uh, optimizing our code. The push down automata is used to design the syntax analysis. So the PDA or push down automata is being used. It is for the PDA, it is the part of CFG. So here's the advantages of the syntax analysis in compiler design. The structural validation. The syntax analysis also allows the compiler to check if the source code follows the grammatical rules or not. If it does not follow, it will report the errors. And it helps to improve the code generation. The code generation part will become easier for any language if the syntactical errors has been detected earlier only. And the easier semantic analysis. Once the parse tree or AST is constructed, the compiler can perform semantic analysis more easily as rely in the structure information provided by the parse tree. And here's the disadvantage. The some disadvantages are the complexity. The designing of this PDA or push-down automatas and the CFGs are really complex in nature, solving these kinds of stuff, and it also takes some time. So overall, it is reducing the performance of our system, and it has limited error recovery. So whatever this grammatical errors which is being defined by the owners or the manufacturer of that compilers, that only it can recover, not every error which is being found. So inability of handle all languages. So every for not all languages have formal grammar, and some languages may not be easily parsable. So the overall, the syntax analysis is an important stage of the compiler design process, but it can be balanced against code. So thank you guys. We are going to meet in the next video.